Good afternoon, everybody. I hope you enjoyed your lunch. We're going to go ahead and get started with our panel, just a couple minutes late. We've got Sam Brown here, who has organized a panel with Travis Dawson, Martin Feather, and Bob Youngblood, and they're going to talk about safety and insurance cases for complex system products. If you have questions in the room, again, please come up to the microphones, and I will be reading questions online. So I'm sitting here for this session. I'll probably hog this microphone if we get online questions. We've got more on either end, and they're open. Thanks.
Thank you, Jennifer. Happy afternoon. We'll deal with all the blood sugar levels in a little bit. I'm Sam Brown, and I've been around here for a little while, and I've been doing insurance cases. With Travis got me started with insurance cases a little over a year ago, almost 2 years. Time flies when you're having fun. And we have brought together, I think, an amazing panel here to discuss insurance cases from different perspectives. First of all, to welcome our panel. In the middle, we have Dr. Youngblood, who's here from INL, and I have all these cool bios. There, I knew I had him. Dr. Youngblood is a senior risk consultant in the Risk Assessment and Management Services Department at Idaho National Laboratory. In this capacity, he works on DOE programs developing probabilistic simulation-based models for system performance. He also does system safety work for NASA's National Office of Safety and Mission Assurance. So he's worked with us, and in fact, really experiencing. We're getting close.
Can you hear me online? Hear me online? Hear me online? All right, we're going to go ahead with this. If they can't hear us.
All right. Pressing on. We'll go. Is there a way to manually advance the...
They just click this arrow down here.
Okay. Assurance cases is a great pepper for lunch. Assurance cases are not much more complex than a structured argument linking a proposition that we would like to show, something that's important to somebody, to evidence. And in fact, we have a definition here which I think works out pretty well, but I'm not going to read that to you. But it's really a very basic argument. How do you connect something that we want to show to our evidence? In IV&V, one of the interesting things about the assurance cases is effectively, this is what we do. I should mention, by the way, some of the original work was by Bill Stanton, who led to the general interest here at the center. A few other people that have come along since then to help along. We've started working, introducing assurance cases in the projects roughly in 2012, which led to a series of capability development projects, CDs, to try to develop assurance cases as a process here at the center. And we have just completed the 2014 CD initiative, where we constructed basically a slice of assurance cases for a real project, describing how that should all play out for us and finding relationships that work well for us. That's a topic for another day. Some of the things that we found that are interesting about assurance cases are the questions of scaling and scoping, how big these things are, how much work is it, what do we have to do. We see there's really kind of three dimensions involved with the assurance cases. Impact, I mean, if you're going to get on a rocket personally and ride it, you would want to make sure that you had a really profound understanding of the assurance that's being provided for you. You would like to talk to everybody that was associated with manufacturing the rocket and so forth. If, on the other hand, it's making coffee in the morning, maybe it's not such a big problem. Familiarity. Unfamiliar products mean that there are more things that come and surprise you. And those are aspects that scale what we want to do with our assurance cases. And coupled with complexity. And of course, dealing with software, oftentimes the complexity aspect of our cube gets pretty large. So the questions we look at is how much of the system are in scope, how do we define what we assure, what we don't assure, and in the end, how much assurance is enough? Have we done the right job at the right place? So with these in mind, considering especially, to me, the unique thing about what we do as IV&V is this sort of assurance is not a side thing that we deliver with the product. We aren't putting together a reactor with an assurance case showing that it can be operated safely. We're putting together assurance. The assurance itself is our end product. The other thing is we have very complex devices that we're dealing with. Software has lots of dimensions, lots of things going on. So we put together a challenge to our panel, which are both vague and provoking. And we hope to address some of these questions in the panel discussion. And we'd like to engage your questions as well. With that, I will turn it over to Dr. Youngblood, who has much better answers than I do. You want to use the mic? Okay.
Thank you. I'm supposed to use this, but I need the clicker. Good afternoon. Sam actually mentioned one of the themes of the few slides I'll have here, and that's decision making. From our point of view, it's important to focus on the point of it all, which is eventually to help somebody make a decision. And as you'll see from the slides, the kind of decision we're talking about is a risk acceptance decision. You know, if you follow risk management at NASA, you know that that's always been there, and it's one of the ways you disposition risks. You may decide to accept them. But lately, for reasons I'll get into in a minute, it seems more and more important to focus on that decision and sort of propagate that back into the assurance activities of the kind that we're talking about here. Okay. Oh, you'll drive? Okay. Before I get too far into this, I'll need to stress that the work I'm doing, a lot of the slides I'll be showing were shown by Homi Desfuli, my main headquarters client in the Office of Safety and Mission Assurance, who actually briefed a group on the subject of safety case. And the group he was briefing is sort of in charge of MIL Standard 882, which is a system safety standard that is mostly used by defense. But they're getting interested in safety case. I haven't learned to say assurance case yet. So I'll be talking here about a special case of the more general thing. Well, and the other collaborators listed there in bullet 2, so including, you may notice, Martin Feather here on my right. So this group is responsible for a fair amount of stuff going on for HomeUn, and I'll be reporting on a splinter of that. But the opinions I express will be solely mine, not necessarily those of NASA or the Idaho National Laboratory, though of course they ought to be. Next, please. Oh, we're there. Okay. No, the one before that. Sorry, I didn't realize you were. No, one after that. Great. Yeah. So these next two slides list some of the influences on system safety, and it would, of course, take way too long to march through them all, but they're kind of interesting. And now go to the next one. Oh, you're there. Okay, we'll highlight a couple of these for present purposes. Sort of 2/3 2000s to present, it's highlighted in black, emphasis on tying safety requirements to safety performance objectives. And then farther down, present and future, increased reliance on the commercial sector with emphasis on technology transfer and commercial crew certification. Changes in acquisition models, increased emphasis on the regulatory side. And the thing that's happening there is that you know, safety cases have been around for a long, long time, and they haven't had much traction in the U.S., maybe outside the process industry. But as people began to ask at NASA, how are we going to be able to put our crew on somebody else's vehicles, on a commercial provider's vehicles? And you know, the question could have come up before, but in my observation at least, it was most pointed, how do people make risk acceptance decisions in the future? And safety case by construction is meant to be the answer to that question. And if you think about the needs of that decision maker, next one please. If you think about the needs of that decision maker, it sort of tells you how hard you have to work in formulating the case, what it needs to contain. And by the way, in the case of human space flight, current NASA policy actually expects the risk takers, the astronauts, to accept risk. So what do you want to give those people? Do you want to give them a grab bag of you know, test results, or do you want a narrative? I actually got interested in the concept well after it was out there in the late 80s. And the thing that appealed to me about it is its narrative. It's not just a grab bag of test results. It's narrative, it's argument, and ought to be much more useful to a normal person than to say, well, I look at the cuckoo accident I analyzed and showed that the thing was okay. Well, that's not the same as showing that it's safe. So risk acceptance has been part of risk management for a long time, but gets increased emphasis lately. The other thing going on, in our minds at least, is that it's obvious in a way, but maybe needs emphasis, that in a modern large project situation, you have a lot of organizations doing things. And so organization A will be providing something to organization B, the acquirer, and B needs to accept the risk that the thing A is delivering may not meet requirements. So in the case of human safety, there's really two levels of risk. There's the level of risk that is got to be there because space flight's dangerous, and then there's a different kind of risk that the system is worse than it's supposed to be. And it's that latter one that we're focusing on here for some purposes at least. So how does B make that risk acceptance decision? And of course, again, the risk-informed safety case is meant to be part of that. Why risk-informed? Well, that's a term we sort of imported from NRC, but it's meant to say that analysis of a risk model or some particular set of metrics are not meant to be the sole basis. You're meant to take everything you can find. So it's a diversity of metrics, and it's the decision should be at least in a deliberative way. Next, please. Okay, acquirer and provider. Well, those are the two parties, and I think there are a lot of good reasons to focus on the existence of those two parties. Not least that the acquirer actually has a lot of responsibility here. If we're talking about the case, it's the provider that's going to make that case, but the acquirer is not off the hook. One of the big horror stories of supposed failure of safety case was an episode in the UK involving a military aircraft called Nimrod. So a safety case was made. Apparently it was pretty shoddy, but it was accepted. And a lot of people died. And in the inquiry, the acquirer was just excoriated for failure to really take seriously looking hard at that case and making a conscious, informed decision. So we've, in our work, thought a lot about what the provider needs. And now on to slide 7. This one is maybe a little repetitive. I may have stolen my own thunder here, but safety cases are supposed to be the answer, but as the Nimrod thing shows, it's possible to do them wrong. The Nimrod inquiry concluded that just calling it a safety case already biases the provider to look only for things that prove the point he wants to make and not look for things that prove the point he doesn't want to make. Risks. And that inquiry actually suggested calling them risk cases. I don't think that solves the problem because the provider, the way things are wired, of course the provider wants the system to be accepted, and changing the name won't do anything. But the acquirer needs to think hard about the case, and so the case has to be scrutable and so forth. And so, in the last bullet, it's just saying, okay, the case idea has been around for a long time, but in our little group, we're trying to specialize it for NASA. Part of the trick here is to do it in a way that reduces project risk both to the provider and to the acquirer. And so an idea that we got out of MIL Standard 882 is to think about the requirements in a particular way early on. So the way to read this is that the top level requirements start out on the left, but then there's got to be a handshake where people think about how they're going to derive practical ground level requirements from the high level ones, what they're going to do to show satisfaction of those requirements. So the provider is saying, here's what I think I need to do to meet those requirements. the acquirer is agreeing that that's going to be enough. And this should work out better for everybody than not doing that. And in a way, it seems obvious, and yet it's an early structuring of the case. So this slide is really, I know from having been in the audience this morning, you can't read all of the print on this one, but it's meant to be about graded approach. How hard do you have to work? Which begins to go to one of the points Sam asked. Up in the left, you're coming in with something you need to analyze. The box in the middle is illustrating a range of techniques from the qualitative and notional down to highly quantitative ones. The answer pops out on the right, and then the challenge on this figure is, do you understand enough about your uncertainty at that point to be able to make your decision in a robust way or not? If you don't know enough to be sure your decision is right, maybe you need to work harder, and that's the loop back. This figure is actually out of the Systems Engineering Handbook. And finally then, I've skipped something important. Back up just to number 8, if you would, please. Yeah, that one. Listening to this morning's talk by Mr. Nkocha, and with Sam's question in mind, what do we have to assure? You know, I'm not a software person, I'm a hardware safety person, and with some reactor background. And one thing that's going on now is, as you may know, they're constructing advanced designs in Georgia. And part of what you have to do when you do that is something called inspections, tests, analyses, and acceptance criteria. So construction goes on for years, and you're supposed to check certain things as you go along. So those are called ITACs for short. And as they began to do this, the NRC realized that they were not used to inspecting construction anymore, because nothing's been built here for a long time, and not used to inspecting advanced designs at all. So there was a little project done to try to figure out what sliver of things to inspect. And novelty was one of the desiderata in that little exercise. Another was stuff you're not going to be able to change later on, because, you know, as you bury things under concrete, you can't check them anymore. So there was a list of things like that were thought about in connection with the ITAC inspection program. And, you know, there isn't necessarily a right answer to that for first of a kind, but they did a little analytical hierarchy process exercise to consider these factors and consider the ITACs. It was dynamic. If people failed in a certain area, they'd inspect that area harder. What has this construction firm done before? So there was the thought process of a kind, and so, you know, to the extent that we can map from one field into another, maybe that's of some interest. Okay, now back to, back now to number 10, where I'll begin summarizing. This is meant to be kind of a summary slide. It's about the acquirer and the provider, and you can see the objectives up on the upper left, and the two-way arrow with you know, the provider and the acquirer doing the handshake. The safety case, the green arrow shooting to the right. The evaluation, which, as I have indicated, we take very seriously, leading ultimately to a decision in the lower right, which I've said we think thinking about that decision is paramount as you go forward. Last one. So, sorry, I've skipped another point. Just go back to 10 just for a second. A point that I just forgot to mention, and I think people generally forget, is that the decision maker, the way decision analysis is written, if you're making the decision, it's supposed to be your uncertainties that govern your decision. You don't get to be told what the uncertainties are by somebody else, like the provider, and then make your decision. It's your uncertainties that drive your decision. And that's why you have to understand this case. And so that yellow diamond there is meant to be serious work if it's a serious decision. Okay, and now on to the summary, please. So, system acquirers need to make risk acceptance decisions. They need to decide whether to accept the risk that the thing they're getting is inadequate. Safety cases are meant to be part of the answer to that. If the stakes are high and the uncertainties are significant, you need all the evidence you can provide. And the provider's risk that he'll work for years on something and then have it turned down is addressed to some extent by the SSRA, the handshake that I mentioned earlier. Thank you.
Terrific, thank you. Dr. Feather?
Okay. Get my slides put up, please.
Didn't I email them to you? Okay.
I emailed them to you.
All right. So thank you for the opportunity to be on this panel. I'm clearly the underdressed one, as I don't have a tie, but I do have my Smokey the Bear jacket. Remember, only you can prevent spacecraft mishaps. Okay. So seriously. So I've been working for several years funded by the Software Assurance Research Program. My co-investigator, Larry Markosian, and I were looking at safety cases and if they would apply to software. Early on, we got some help from John Rushby from SRI, Dr. John Rushby, who's a really deep thinker on issues of complex algorithms and software and fault tolerance, and was very aware of the safety case field. So it was very helpful to have him involved. And then, as Bob mentioned, more recently I was able to join Humayun Desfouli's team working on system safety with a perspective on the system, not just the software part. While we were doing our work, there were some other developments that took place here in the US. So the US FDA, Food and Drug Administration, moved towards a guideline for infusion pumps, things that pump drugs or painkillers into people, which nowadays have a lot of software controlling them. And they were concerned that software bugs were causing more problems and recalls of those devices. So they actually produced a guideline. I think it's still a guideline, not a requirement, but they seem to be requiring it more or less. That when a vendor provides an infusion pump, they also provide a safety case or an assurance case to argue why it's going to be safe. And so that was an interesting development here in the US, whereas previously most of the work in safety cases seemed to have been going on in Europe and Australasia and so forth, but hadn't made much inroads into the US. Another thing I think you ought to be aware of is at NASA Ames, there's a group developing a safety case tool. So if there was serious interest in NASA in applying safety cases, then this group, their tool is called Advocate, and the principal developer is Dr. Ewan Denny, and the Ames civil servant point of contact is Joseph Coughlin. And so they've developed a software tool. There are other ones in the commercial world that handle safety cases, but if we want one that's a homebrew NASA tool, there is one under development, and they kindly let Larry and I use it in our training course. I mentioned that I'm on Humayun's team. Oops. Okay, there's something that came to my attention fairly recently from the National Defense Industrial Association, the NDIA, who worry about cybersecurity. And they released a guidebook this year which was focused on cyber attacks, which I'll have something to say about tomorrow on cyber defenses. But what I noticed in their guidebook was they had a a nice definition of assurance, and I'll read it to you. System assurance is the justified confidence, and I really like those words, justified confidence, that relates to Bob's thing that if you're the acquirer, you have to be confident that the thing you're acquiring is going to be safe, and you have to be justified in that confidence. So if someone comes along afterwards and challenges you, why did you accept that crummy system, you can point to all the good things you do to assess its safety. Anyway, so their definition is system assurance is the justified confidence that the system functions as intended, vulnerabilities, blah, blah, blah. So they're in the cyber world where they're worried about vulnerabilities. But I like the idea of justified confidence. They also spoke to the need that you can't, in the cyber world, you cannot exclude vulnerabilities with absolute certainty. So you have to do some sort of risk assessment and proceed accordingly. They made a big deal of assurance cases. The same thing, the assurance cases are safety cases that we've heard about. So they see them as the argument, the way of presenting the argument for why a system is sufficiently absent of vulnerabilities. Now, I actually think that they've absconded with the word assurance because they've tended to use assurance in the cyber community to mean absence of vulnerabilities. But in the more traditional software development world, assurance means checking all the good practices development, not just the vulnerabilities, but does it have actual bugs? Does it have requirements mismatches and so forth? Anyway, the last thing that I got out of this MDA guidebook was the usual description of assurance cases consisting of a claim, an argument which breaks down into subclaims, context that tells you when the argument is applicable, assumptions that have to be true to make the argument valid, and at the bottom, evidence, things that you do like testing, analyses, inspections, peer reviews, and so forth, that give you the belief that that part of the argument in fact holds. And what they added in addition was this notion of criteria, which goes along with evidence. And they said criteria are used to determine whether certain evidence acceptably supports the argument. So I was thinking about that this morning in the talk on which was it, the combinatorial testing thing. It's not just, you don't just need to know, have I done a certain percentage of test coverage? You'd like to relate that to what confidence you get as a result from having done that level of test coverage. So I noticed that in the NDIA document that they have this call out for criteria to say what is necessary and sufficient evidence to support this claim. Anyway, so getting back to the work that Larry and I did on our SAP funding task, we got into it because we heard originally from John Knight, who's quite well known in the field of promoting safety cases. We also read the NRC report, Software for Dependable Systems, that Daniel Jackson led the panel that led to the writing of that report. The need for things like safety cases to argue convincingly of the safety of a system. And based on those things and some of the things we looked at, we applied for and acquired some research funding. What I naively thought was we'd look at these safety cases, find out they were a great thing, tell that to NASA, and they would be wholeheartedly adopted. It didn't quite work out that way. And so what we did was we read a lot of papers, well more than 50. I think I've got up to 100 of the things now, from the United Kingdom Ministry of Defense. The CMU Software Engineering Institute had done a paper on safety cases using a NASA system as an example over a decade ago. There's a company in the UK, Adelard, that has a safety case tool. There are a huge number of papers by Tim Kelly from the University of York, who everything you might imagine to ask about safety cases, he's written a paper about it, is my impression. Anyway, so Marshall at that time developing a system that was to go on the Ares 1 rocket. And we did develop parts of a safety case for some of that system, which I'll tell you about in a minute. And then finally, we developed a one-day training course on safety cases for software systems that we piloted to our software assurance group and a few management folks at JPL. And then we gave it again at the NASA software working group meeting about a year ago. Okay, so the work we did with the Ares 1, there was Ares 1, as you might remember, was Constellation's rocket to launch the astronauts into space. So clearly, safety critical things arose throughout its design. The one that we focused on was a piece of software called the Abort Failure Detection, Notification, and Response System, the duty of which was to recognize, given symptoms from various sensors scattered around the rocket, whether the rocket was failing catastrophically beneath the astronauts, and therefore they should abort the mission. And Ares 1 was designed to have an escape mechanism that could accelerate the crew capsule away from the rocket and parachute them safely to Earth. Of course, that would be the end of the mission because the rocket's presumably failing as they're safely parachuting away, the rocket is blowing up or going off target or whatever. So the software in this system was to recognize the need for an abort. So it was clearly safety critical. It had to both recognize when there was a need for an abort, and it had to not misrecognize, no false alarms, because if it told the crew, you need to abort now, and they aborted, and there was no need to do so, the mission would be over, and it would put the crew to some risk, because the system that gets them away from the rocket has to have quite high accelerations. So it was almost as safety critical that it have no false alarms as it was that it have recognized true abort conditions. We had the chance to work with the people essentially developing the requirements and prototyping that system so we could talk to them. They also gave us access to their 600+ page documentation, which is a clue right there of a problem. And in going through that and developing a safety case, we had some interesting exchanges with them, trying to understand what they had written and giving some of our feedback to them. And we focused on the false positive thing, the false alarm part, because that seemed to be the hardest thing. For software, it's a challenge to show that it will do the right thing when it's supposed to, but I think it's an even bigger challenge to show that it won't do the wrong thing when it's not supposed to. So we were curious to see whether safety cases would help us explore these false alarm situations. And we did that work because it was Ares 1 and it was a rocket, and this was a critical piece of software. It was all ITAR. So that was a big impediment to our effort, actually. We couldn't publish specific details. So in the end, what we did was we generalized away from the specifics of the rocket and said, well, what we're really interested in is this system has to recognize when it's a critical condition. It doesn't matter whether it's a rocket or an airbag controller in your vehicle. It has to recognize when it's a critical condition and yield some notification accordingly. So by moving away from the details of Constellation, we were able to produce a non-ITAR course. And I think that's actually a problem for the field. There are not very many true examples of safety cases or assurance cases because people don't want to publish the grubby details of how their system has these perhaps little vulnerabilities in it, which could then be exploited or criticized. So it's hard to see real examples of these things. There are a few. John Knight has a repository of examples, usually European ones, of safety cases. But I think the field lacks that experience base. We did some work to try and tie what we saw was going on in safety cases to we've got slides. If we could move along, probably 2 or 3 more. Yes. So I won't try and go through all the details of this, but we found that we could pretty much relate everything in the NASA software safety standard to where it would be represented in a software safety case. Some of it was at the system level, so we saw that the AFD&R system was allocated a probability of false positives and allocated a probability of false negatives and told to remain within those probabilities. And so we could trace how that flowed down to the subsystems. But once we got into the software, dealing quantitatively with probabilistic behaviors of software, we just gave up at that point. It doesn't seem to flow well into the software itself. Some people have worked in that area, but we didn't feel confident trying to push the numerics down into the software. We found that there was a place in the safety case for relating to the natural software development, the green thing in the top right, where you start with requirements and you show those requirements are met in the design, and in your argument in the safety case, you show that the design is fulfilled in the code, and then that code is realized in the executable, perhaps by arguing that you've used a well-trusted COTS compiler, for example. We also saw the place for the bottom right, the things you worry about generically in software, like if there's another piece of software running on the same computer, can it interfere with your software, or can your software interfere with someone else's software? You always worry about interfaces. You always worry about memory overlap and inadvertent sharing of pointers and memory space and so forth. And just basic hazards like divide by zero, which things like static analysis are really good at eliminating. And then we found some interesting sort of sub-patterns. There's a notion in safety cases of patterns, like design patterns in software engineering. There are these safety case patterns, which are sort of recurringly good ways of organizing bits of an argument. And we found one, or we maybe rediscovered one, that was to do with when you have a subsystem generating a result, which is then used by another subsystem. We thought it was interesting to argue three things: that the result it generates is correct, that the system that receives that result does the right thing with it, and that the interface between the two doesn't mess things up. So they both agree at both sides on what the communication will be. So we found that there was this use of software patterns as well. Next, please. Okay, so we were instructed in our challenge to the panel what approaches have been effective in managing assurance in complex projects, not necessarily assurance cases. How do you decide what to assure or not to assure, and what new challenges should researchers address in handling large systems? Well, the first point, at JPL, you've I'm sure heard of the Curiosity rover, Mars Science Laboratory. An interesting paper written by Holtzman recently described how the software on that system was developed with a very thoughtful and rigorous process. They did not use safety cases at all, and yet they were able to organize the way they went about developing, assessing, verifying, testing, reviewing that huge piece of software with very effective results. So there are approaches out there that NASA already conducts that do software development well. So a good question is, do we need safety cases for software? So next slide, please. So we were also asked to think about scaling and scoping of assurance cases. And I realized I'd misunderstood the three axes of the cube. Complexity, maybe I got that one right. When Larry and I were doing our work, we were given this 600+ page document. So part of the challenge, if you're not part of the development team in off the side doing a safety case, which is what we were really doing, is getting up to speed on all the intricacies of the system you're developing the case for. So this just reinforces the usual suggestion that it's best of all if the people developing the software are also the developers of the safety case for it. The familiarity axis, I took this a very different way. When we piloted our safety case one day training class at JPL, some of the reactions were essentially people were put off by the unusual terminology. So if you read the safety case literature, they talk about goals and context and arguments and strategies, none of which relate to the way people doing software development tend to think about their work. So just the simple things of the naming that we get so accustomed to when we're seeped in the software, in the safety case world, is unfamiliar to much of our target audience. And then the third axis, impact. I think the suggestion was impact should be, where should you focus an assurance case? On things that have high risk, presumably, rather than things that have low. But another notion of impact is, what is the impact of adopting an assurance case? Does it actually make things any better? And how would you prove it? Because we obviously cannot afford to develop a system twice, once with safety cases or assurance cases and once without, and somehow compare the results and say, well, that one was safer than that one. So arguing the case for assurance cases and proving it is extremely difficult. And then the last thing I circled on this slide, how much assurance is enough? I think that's a fundamental question. So let me go to what's probably the last slide. So my colleague Joel Wilf and I jokingly call this the fundamental assurance question, the FAQ. So we've stolen the FAQ acronym, which is, how much confidence do you get from doing some kind of assurance activity? Like if you do process assurance, if you're a traditional software assurance organization and you check that the development folks are following the processes they said they were going to follow, how much confidence do you gain, and in what respect from having done that? If you do a peer review of a design, if you do a formal inspection, a rigorous review, if you do testing, like we heard this morning, you can get confidence from looking at what the test tells you. If you do static analysis, yeah, it's really good at eliminating certain problems, but is it 100% sure to eliminate its class of problems? You have to think about false negatives. Model checking is often touted as a very appropriate approach for concurrent software, and indeed it is. But the question always arises, if the model checking doesn't finish, you let the thing run and run and run, and it's still actually, because the problem is too big to solve with current technology, do you actually get any confidence from having let it run so far and not found any problems? And then even theorem proving, which people do for the most stringent requirements, you have to wonder, okay, the theorem might be right, but was the specification wrong in the first place? So I've proved a truth of something that was irrelevant to begin with. So I think these are questions which underpin all software assurance and V&V. And the nice thing about assurance cases is that they really bring them to the fore. That you're asked to organize a safety case, as we saw in that diagram at the beginning, into a breakdown which bottoms out at little claims and evidence that supports those claims. So if you claim that your piece of software is free of divide by zero defects, and your evidence is you ran a commercial static analysis tool that is fully capable of identifying all possible divide by zeros, perhaps with some false alarms, but will never miss one, then you've got a very, very strong piece of evidence. But a lot of those claims are less absolute than that. So figuring out where the things you've done give you the confidence you need, I think, is a really key question. And there's an interesting paper I just finished with, well, two things. One thing I didn't put on the slide, Michael Holloway at NASA Langley has been using assurance cases to rationalize the DO 178C standard, the latest software development standard. So the standard is a fairly typical, fairly prescriptive standard that tells you what to do and so forth and how to do it. But it's not really strong on why those things are good to do and what they tell you when you do them. So Michael Holloway has been using safety cases or assurance cases to record that justification, so that when you come to the standard and you say, well, why do I have to do this thing? There'll be, as I understand it, Holloway will have developed a rationale which will be easy to understand for what you're getting from following that step in the standard. So I thought that was an interesting use of assurance cases, different from just saying a project should develop them. And then this final thing on the slide, there's a paper I would recommend you read by this person, Tim Kelly, who's published widely. This one you can find on the web. The title is Software Certification, Where is Confidence Won and Lost? And he actually contrasts prescriptive standards like DO 178C, or in the NASA world, the equivalent would be the NASA software development standards and the NASA software assurance standards and the NASA software safety standards. Well, maybe not the safety standard now, but the old software assurance standard, which are very prescriptive to say for a certain level of criticality, you do these kind of things. Kelly's paper contrasts those with what are their strengths and weaknesses relative to what you would get if you were doing a safety case. And I think the takeaway I got from reading his paper that those standards are very good things. You ignore them at your peril. So if a standard says you should be doing configuration management, you probably should be doing configuration management. But what the standard is totally unable to do is be specific to your project. Of course, it's a standard that has to be written for all projects of a certain class. And so when you have your specific project, there may be greater or lesser need for the way you conduct a step in that standard. And the nice thing I think Kelly pointed out about safety cases is they can be very clear about stating why and where you're doing these things. So just in conclusion, Larry and I, well, I guess I'd take the blame. We're naive in thinking that we would just explore safety cases and projects at JPL and elsewhere, and NASA would leap to their adoption, and that's not happened yet. Although I'm encouraged by the interest that Dr. Homayun Desfouli has created in pushing for safety cases for systems. But we certainly didn't succeed in getting them adopted right off the bat. So I think it's a long-term effort. I think there are ways to use them. I'm interested to learn more about how IV&V is using them. I think they don't just have to be used by a project that does them all or nothing. But I still am a fairly strong believer in their utility. But nevertheless, safety cases or standard processes, I think this is the key question. How can you attribute the assurance you get, the gain in confidence from doing the things that software developers and assurers and inspectors do? Okay, thank you.
Thank you very much, Martin. Travis?
So as Sam said, I'm the task chief engineer here at the NASA IV&V program. I have 2 minutes. Thank you very much. Any questions? No, I guess I'll leave out most of what I was going to say. I don't have any charts. I did have a couple of remarks I wanted to make. I'll try to do that quickly. I would say the most important thing I was going to say is that assurance cases here at the IV&V facility lie at the intersection of two concepts, which are themselves related. One is this concept of evidence-based assurance. Within IV&V for quite a while now, our analysis consists of taking experts in different domains and different systems and have them analyze various products in very technical ways, but the product, the output of that, is primarily two things. One is somewhat of a qualitative assessment of how good the system is, and the second is a list of issues. And there's a goal here at the facility to shift to more of an evidence-based assurance mindset. So that means that we build up assurance in the, if you think of like a risk burn down as a concept, think of building assurance as you collect different aspects or elements of the assurance. And so moving from an issue, bug, defect mindset as our output to assurance as the product of the IV&V facility And the other concept is the concept of assurance itself. I mean, the program considers its product to be safety and mission assurance. Its product is not a list of defects. So while defects will always be an important output of what we do, I'm certain that is not the product. So if you say your product is safety and mission assurance, what exactly is assurance? And assurance cases give us some promise that they'll be able to provide that defined assurance or even quantified assurance. And then secondly, it's a way, again, to build assurance. And at the end of the day, you have something you can state as a positive. I have provided the following assurance, not I found the following list of defects. If you fix all these defects, I can guarantee that you fixed all the defects. I can't guarantee your system will work. And that's the goal, is to guarantee the system it will in fact work and work safely. Was I close? 2 minutes? All right, great.
Thank you, ladies. Thank you, gentlemen. Appreciate it.
So anybody on site, these gentlemen will be in the room today. If you have an opportunity to ask them a question that you didn't get to ask them today, I encourage that. We're going to go ahead and move on with our next presentation.